Question number 9. This question is of integration. A curve which passes through this point 0, 3 has equation y is equal to fx. It is given that f dash x is equal to 1 minus 2 over x minus 1 whole cube. This is the gradient of the curve, and the point is also given through which the curve passes. Find the equation of the curve. Gradient of the curve is given. We have to find the equation of the curve. Gradient expression is f dash x is equal to 1 minus, we can write this 2 over x minus 1 power 3. So we can write it as 2 into x minus 1 power negative 3. This is the gradient expression. Now we will integrate each side with respect to x. When we integrate both sides, f dash x becomes fx. Integration of f dash x will be fx. So we write here fx. Right side will be integrated 1 minus 2x minus 1 power minus 3 with respect to x. Now we will integrate right hand side. Fx will be integration of 1 will be x minus 2 remains as such, x minus 1 minus 3 plus 1 over minus 3 plus 1 plus c. This is c is the constant of integration. Now we simplify it. Fx is equal to x minus 3 minus 1 minus 2. This is cancel out, minus minus plus. So here we will write x plus x minus 1 power negative 2 plus c. Now this is the equation of the curve. This is the equation of curve. Now this curve passes through this point 0, 2, putting this point on this curve because this point lies on the curve. 0, 3 is the point which through which the curve passes. Putting here x coordinate is 0 and y coordinate is 3. Y coordinate mean fx. The value of fx is 3. Value of x is 0. Putting here, we get 3 is equal to 0 plus 0 minus 1 power negative 2 plus c. Simplifying, 3 is equal to negative 1 power negative 2. This becomes 1 plus c. So from here the value of c is 2. Now equation of curve, we will put this value of c in this equation. We get finally equation of curve is equation of curve fx is equal to x plus 1 over x minus 1 square plus 2. This is the equation of the curve. The next part of this question is part B. The tangent to the curve at point 0, 3 intersects the curve again at one other point P. Show that x coordinate of P satisfy the equation 2x plus 1 into x minus 1 whole square minus 1 is equal to 0. Tangent to the curve at 0, 3 intersects the curve again at one other point P. So first of all, we will find the equation of the tangent which passes through 0, 3, and the equation of the curve is given. We will solve the equation of tangent and equation of curve to get this point P to show this relation. Now to find the equation of the tangent, first we will find the gradient of the tangent. Now the gradient of the tangent is given in the start of the question. F dash x is the gradient. This is the f dash x. This is dy by dx actually. Gradient is given. This is the gradient of the tangent. Dy over dx is 1 minus 2 over x minus 1 power 3. Now at this point 0, 3 point is given 0, 3. So putting this point, the gradient will become, we will use the value of x, that is 0. So gradient will be dy over dx 1 minus 2 over 0 minus 1 power 3. From here we get dy over dx, that is the gradient of the tangent, equal to 3. Now equation of tangent, now we have gradient of the tangent 3 and the point is 0, 3. So equation of tangent will be equation of tangent y minus 3 is equal to gradient x minus 0. So we get equation of tangent y is equal to 3 plus 3x. This is the equation of tangent. Now equation of curve is also given. Equation of curve is equation of curve we have found just. This is the equation of curve. Actually, this is fx is equal to y is equal to x plus 1 over x minus 1 whole square plus 2. This is the equation of the curve. Equation of curve is y is equal to x plus 1 over x minus 1 square plus 2. Now we will solve these two equations simultaneously. This is the equation of tangent. This is the equation of curve. We will solve these two equations to find the point of intersection. Now we will put this value of y here. We get x plus 1 over x minus 1 whole square plus 2 is equal to, substitution method. 3 plus 3x, simplifying it, x plus 1 over x minus 1 whole square minus 3x is equal to 1. Minus 3x plus x, that is minus 2x, minus 2x plus 1 over x minus 1 whole square is equal to 1. Now 1 over x minus 1 square will be 1 plus 2x. So by cross multiplying, we get x minus 1 whole square into 1 plus 2x minus 1 is equal to 0. This is verified. We have to verify this. We have to show that the x coordinate of P satisfy the equation this, or we have shown this equation. Now next part of the question, the part C, verify that x is equal to 3 over 2 satisfy this equation and hence find the y coordinate of P. We have to verify that x is equal to 3 over 2 satisfy the above equation. Now putting this value of x in the above equation, equation is x minus 1 square into 1 plus 2x minus 1. We have to show that when we put this value of x 3 over 2 in this expression, we get 0 on the right hand side. So putting this value x is equal to 3 over 2, putting here 3 over 2 minus 1 square into 1 plus 2 into 3 over 2 minus 1. Simplifying, we get 1 over 4 into 4 minus 1, cancel out, 1 minus 1, that is 0. This is verified that x is equal to 3 over 2 satisfy the above equation. Because on the right hand side is equal to 0, we have shown. Now next we have to also find the y coordinate of point P. Now putting this value of x in y, we have y already found, fx the equation of curve we have already found. This is the equation of the curve. Fx is y, so we will find the value of y by putting this x is equal to 3 over 2. Y is equal to x plus 1 over x minus 1 square plus 2. Putting this value of x 3 over 2 here, we get the value of y. So y is equal to 3 over 2 plus 1 over 3 over 2 minus 1 square plus 2. After simplifying it, we get the value of y, that is 15 over 2. This is equal to 3 over 2 plus 4 over 1 plus 2. So finally we get y is equal to 15 over 2. This is the answer.